Hello everyone, Silix Orion here. I just wanted to show you a really neat old GPU from my collection. See, now I'm working with a new setup. I don't have a camera to record live, which is why I have pictures up here. So please politely let me know how you might not even be able to hear me, how the audio and quality is for this video. It's probably going to be like this for a little while, but as I get set up, should slowly improve. So anyway, we're a minute in, we haven't even gotten to it. So here, let me try that again. This is something with a really long name. Here, let me pull up my notes. It's this. The NEC 980-000212P 0146412 VGA adapter ISA card. So this card, I covered my audio tracking. This card is I think manufactured in the 90s, but it's got copyright 1987 somewhere. I promise it says copyright 1987 somewhere on this card. So I believe that this was, and the GPU on it, we'll get to that in a minute, was released in 1986. So I believe that this was, it started development from 1987 to 1990, I believe, is when it came out, because I looked up some of the numbers, specifically the RAM chips over here, which we'll also get to, and they were released in 1990. I guess I'll quit wasting time and get to the interesting GPU and basically any other modern card. Oh my god, my audio is clipping. And basically any other modern card, basically what you're going to see is it's on the left, and that's how you're going to insert it into the computer 90% of the time. So that's, oh my gosh. I apologize for the audio. The setup's absolutely horrible. So you'll see this like I said, it's on the left. So maybe it's on the back here. Let me look. Copyright 1989? Yes, 1989. I apologize. Copyright 1989. So that would make this GPU 37 years old. So I believe blah blah blah. Let me just get to the next interesting point. So this is on the left side. That's interesting enough. You might have noticed when I went over to show you these pictures, the slot looks very different. The slot, you can see, here's the slot. Here's the more modern cards. This is the modern standard PCIe. You'll see that the pins are so close together, but this one, the pins are very, very far apart. This slot standard is called the ISA, Industry Standard Architecture slot. It was a 16-bit bus interface developed by IBM in 1984 for personal computer expansion cards. It was the mid to late 80s equivalent to the modern PCIe, which we use for practically all expansion cards nowadays. This interface was superseded by the EISA, extended industry standard architecture bus, which looks like this. I don't know if I got a picture comparing an EISA card to an ISA card. I should have. Here. You'll see that the slots are basically exactly the same length. That's because this slot is a extended 32-bit version of this slot. A ISA card will work in extended ISA motherboard, but an extended ISA card will not work in an ISA slot on a motherboard. So the EISA standard was then superseded by the PCI standard. The Extended Industry Standard Architecture (EISA) was announced in 1988. And the normal and the ISA was 1984. So that would be 4 years later. PCI was released in 1992. So we've got 1984, 1988, 1992. And it was superseded for graphics cards, at least, by the Accelerated Graphics Port, AGP, which looks like this. So you can see how it looks a bit like the EISA card, in the way that it's layered, right? So this has kind of 2 layers of pins, and AGP also has 2 layers of pins. AGP was superseded by PCIe. It was released in 2003 initially, and it's basically what our modern connections are based off of. I believe we're currently on PCIe Gen 5. Yes, we're on PCIe Gen 5. This is a Gen, I believe this is a Gen 1 card. In this picture here, this is a hot mess, but I felt like I needed to document this card because I really could not see much about it. Okay, so we've covered the slot, we've covered, oh my gosh, we really haven't covered much. Okay, so I guess the next interesting thing that would be the VRAM, which is over here. I looked at, you'll see some of these are bent. They're really fragile, and it was like that when I got it. We'll see. There are 32 of these chips. Are they chips? There are 32 of these integrated circuits. Each one is a 256. Each one is a 256 kilobit VRAM module. Because this is a dedicated VRAM module. With 32 of them, that's 8,122 kilobits, which is 1,024 kilobytes, which is 1 megabyte of VRAM. So this card has 1 megabyte of video memory. If I go back to pictures of these other cards, one second. These are all old cards, so none of these are particularly modern. But this one, I believe, has 32 or 64 megs. This one also has 32 this one has 32 megs. This one has 32 or 64 megs, I believe 64. And this one has 128 megabytes of video memory. 256 megabytes of video memory. None of those are particularly good. In fact, all of them are completely obsolete by modern standards. Modern video cards, 8 gigabytes of video memory is like very much the low end of what you would have a good time using for gaming and highly intensive workloads and things like that. This chip made by the Chips Company, the F82C451 plus a bunch of other alphanumeric characters is the main IC. This is the graphics controller, which I actually don't know what it does. Oh my gosh. Okay, hang on. Okay, yeah, so Google AI just did what it does best and completely misread what I was trying to say the first time. But okay, so basically, on a motherboard, which conveniently I have a picture of, So let's go here. Because a GPU is very much just a normal compute. It's very analogous to a full-on computer. So let me just looking here. We have the CPU. This is the actual. If we're doing the analogy with. If we're doing the analogy to a graphics card, CPU is going to be the actual graphics processing unit. These are DIMM slots. This is where the RAM goes. So this is going to be your video memory. These are you're not really going to find expansion slots on a decent modern GPU. But we've got a BIOS, which I don't think we've gotten to either. We have power delivery. We have I/O. And we have the chipset. This is the chipset. Basically, what a chipset does on a motherboard is it takes base. Oh my gosh. A chipset, sometimes it multiplexes, basically, like, jumping between, like, streams of data rapidly so that it can communicate with more than one. Like, say you could only communicate with one stream of data at a time, and you wanted to communicate with 6 streams of data, you would just communicate with stream 1, then stream 2, then stream 3, then stream 4, then stream 5, then stream 6, really rapidly. So you were effectively communicating with all 6 at the same time. That's what multiplexing does. A chipset basically just, via either multiplexing or some other method, takes the limited resources that the CPU can handle and splits it between a bunch of different I/O connectors. Old chipsets controlled the RAM. This chipset, if we follow the traces, control the PCI slots. There's quick lesson on old motherboards. We have a north bridge and a south bridge. The south bridge basically controls all of the system information, and the north bridge controls all of the I/O. So, we have down here an ISA slot. So that's the connector that our GPU has. We have an AGP slot, which is broken over here, and we have a PCI slot. And we have this one, AMR. I actually don't know what AMR is. But, so yeah, that's the chipset. It allows the CPU to interface with more than it normally would be able to, unfortunately at the cost of data transfer speeds. So that's what... So we have our chipset, we have our BIOS, which basically, on a motherboard and on a GPU, what a BIOS does is so your CPU, when you pass power through it, it doesn't know how to do anything. It has to be babied into doing every little thing that it needs to do. That's the job of the BIOS. Stands for Basic Input-Output System. It has been superseded by UEFI, which I'm not even going to get into because 19 minutes, and we really haven't gotten through much. A BIOS basically, when you pass through power, it does magic, and it teaches your CPU everything that it needs to do. And so this is a BIOS on our GPU. I was able to find one on a few others in the pictures that I've showed you, but like, not sure I want to go through finding those again. So we have our graphics controller, we have our BIOS. This guy is the interesting one. This is the TMS 34010FNL. This is actually the first ever legitimate GPU, like actual dedicated graphics processing unit ever made. Released in 1986 by Texas Instruments. It's actually this guy. Developed by Texas Instruments, released in 1986, was the first programmable graphics processor integrated circuit. While specialized graphics hardware existed earlier, such as bidders, a TMS 34010 chip is a microprocessor which includes graphics-oriented instructions, making it a combination of a CPU and what would later be called a GPU. So this is basically the first legit GPU ever. This is the precursor to the chips inside of your graphics cards, the graphics processors in your laptop, in your CPU, all graphics processors. This is the first one basically. We've already covered the 1 megabyte of RAM. We have oscillators. These guys are basically just the clock. These guys. Oh my gosh. These guys are the heartbeat of your GPU. They are a reference for everything. Every bit of data that comes through this bus, these clocks help synchronize it with your GPU and your chipset and your RAM and all of our core components, basically enabling them to be processed easier. Not easier, I mean like really at all with this kind of architecture. If we go to this picture here, we can see, first of all, there's a sticker down here. I forget I can't zoom. Let me just... I promise my videos will be better once I get a camera that I can actually talk to live. We have a sticker about this device complying with Part 15 of the FCC regulations, and we've got our lone VGA output. My notes here have a really long rant about what VGA is, and I felt like, if you don't know, VGA is just like a really old analog video connector. But I doubt you didn't know that and understand everything else I've said. Cooling and processor. That's a good point, me from the past. Thank you. I never would have thought to say that. So if we go to this image here, you'll see that not only is there no cooler for, let me get this out of the way. Not only is there no cooler for our GPU, the GPU is encased with insulating resin. You might be thinking, why would they do that? That sounds stupid. The reason they did that is because GPUs really were not power hungry enough to produce much heat anyway. It would get warm, sure. Processing, like, holy cow, 256 colors, and maybe even a thing that you can click on. Because I've only really gotten this GPU to display text. I really should have gotten footage of it working, but again, my setup is kind of hot garbage. I'm probably going to upload some footage of that as a short later, but they didn't use any cooling because it really didn't need cooling. That as compared to even this one, this was a decently powerful 2D accelerator. I say decently powerful and 2D accelerator in the same sentence. This could not display 3D images. This could load your desktop as long as it wasn't Windows Vista or anything 3D. But anything that's even moderately powerful, like this AGP card, has a cooler on it. An active cooler, nonetheless, with a fan. This was really completely unheard of at the time for GPUs. And this guy, even more powerful active cooler. But yeah, this is honestly a really cool time capsule. A really cool time capsule from a era of VGA and 1 megabyte of VRAM. 1 megabyte across all of these chips. And I find this quite interesting. It felt like I needed to document it because I couldn't find much information on this board out there online. The name of this board, if you wanted to do your own research, is NEC space 980-0002 space 12P space 01464112 space VGA space adapter space ISA space card. That took like 4 takes to get right. So, like I said, this is a pretty cool time capsule. I am going to stop the recording and start editing because I have a feeling it's going to take quite a while. I have like 28 minutes of footage. So, anyway, still looks alright. Signing out.